Hello everyone, this is just a follow-up to your textbook on dimensional analysis and converting from one conversion factor to another. You will need your equalities and conversion factors list that I have provided for you on Blackboard, and there's also one in the back of your textbook. But this will help you because you'll be given this for your test. Okay, so we're just going to work some problems. Okay, the first problem says, the average African gorilla has a mass of 163 kilograms. What is this mass in pounds? So it may be beneficial for you to pause the video, try to work this yourself, and then play it to see if we got the same answer. So you can do that as well, or you can just watch it through. Okay, so if we think about this, the first thing that I always tell my students is that you want to write out what you're given and what you know. And so right now, what we know is that we have a 163 kilogram gorilla. After I write that out, I always go ahead, put my multiplication sign, draw where I'm going to have my fraction, and then put kilograms in the denominator. The reason for this is because our units have to cancel. So kilograms has to cancel with the diagonally with kilograms on the bottom. So before we go any further, we can always write out what we know and then put our units on the bottom for them to cancel out. Okay, we are asked for the mass in pounds. Okay, so if you look at your conversion factor list, you will see that you should have under mass that 1 kilogram is equal to 2.205 pounds. Okay, so easy enough. Since we need pounds, all we have to do is find one common relationship and plug it in. So we see that 1 kilogram is equal to 2.205 pounds. So our kilograms can cancel. And then we multiply the numbers on the top and divide them by the numbers on the bottom. Here we just have 1, so it's going to be 163 times 2.205 divided by 1. And so our answer comes to be 359 pounds. Okay, another problem. A Chevrolet Impala holds 4.50 quarts of oil. All right, so the first thing I said to do always is to write out what we're given. And then here I'm just drawing, instead of the multiplication, just drawing a little dot. It's understood for multiplying. Okay, so now we have to find a common relationship or common relationships that will get us to milliliters. So if you want to pause and go look at your conversion factor sheet, you can, okay? But when I do this, and sometimes there's more than one way that you can work the problem, but what I see is that in 1 quart, it's equal to 0.9463 liters. So 1 quart is equal to 0.9463 liters. Okay, and then if we need milliliters, we know that there's 1,000 milliliters in 1 liter. Okay, and once again, these will be given to you. Things like 1,000 milliliters in 1 liter, that's something that you want to pick up on. It will be given to you for the first test, but you want to be sure you pick up on those. Those are very simple ones to remember. Okay, so we have 1 quart is equal to 0.9463 liters. Okay, so our quarts will cancel. And whatever you're left with on top as your units is the units that you are supposed to be trying to find. Okay, so here we have liters on top, and we know that we are looking for milliliters. We're not looking for liters. Okay, so we know we have to do another step. So before we plug in anything, we know if we have liters on top, we have to have liters on the bottom to cancel. Okay, in 1 liter, there are 1,000 milliliters. Now our liters can cancel. We're left with milliliters as our units, which is what we're trying to find. So we can stop here and multiply 4.50 times 0.9463 times 1,000, and then divide it by 1 times 1. And we should come up with about 4260 milliliters. As far as for your significant digits, we know that we're multiplying here. However, our 1,000 and 0.9463, these are exact numbers, okay? They're in the chart for us as an exact number. So we need 3 significant digits, and so that's how we got 4260 here. These are our 3 significant digits. Okay, now we're going to look at length, an example of length. Okay, we want to calculate the number of inches in 4.525 kilometers. So the first thing we always do is this. Because now we have our units on top, units on the bottom, and we know that our kilometers have to cancel. Okay, so now we have to look at what our common relationships are. How are we going to get from kilometers all the way to inches? Okay, and how we're going to go about doing this is we're going to go from kilometers to meters to centimeters and then to inches. So sometimes the hardest part is finding the plan that you're going to go through to get to the desired units, okay? And so here we know that in 1 kilometer there are 1,000 meters. Okay, so right away we can get closer to an inch. Okay, so our kilometers will cancel. We're left with meters on top, so we've got to have meters on the bottom. Okay, we're looking for inches, so we have to keep going. Okay, the next thing we know is that in 1 meter there are 100 centimeters. So our meters can cancel. We're left with centimeters. Okay, now we want to go to inches. And so most of you probably already know, but it is in your table, there are 2.54 centimeters in 1 inch. Our centimeters cancel. And if we multiply everything on the top, divide it by the bottom, everything multiplied on the bottom, we would have 4.25 times 1,000 times 100 divided by 1 times 2.54. And we should get something like this as our answer. And since this is a large number, we put it into scientific notation. Okay, so we're going to do one more with length. Okay, we want to find meters from miles. So if we have 0.200 miles, we write out what we know, what we're given first. Okay, write out our fraction, put the miles on the bottom. We know that has to cancel. Okay, and we want to go to meters. Okay, so if we look at our conversion factor list, what I see is that we have in 1 mile, we have 1.609 kilometers. Okay, so our miles can cancel. All right, and now we want to go to meters. And so we know that in 1 kilometer, there are 1,000 meters. So if we do the math here, we should get 321.8 meters, which we can round that to 322. Okay, we've got 3 significant digits here, and so we want 3 significant digits in our answer. Okay, this concludes some extra practice or extra problems that are not in your book that will hopefully help you with dimensional analysis. Just remember to use your conversion factors list, practice and practice finding the common relationships and the path that you're going to take in order to get to the units that you desire to find.